Okay, so we're going to do solving one-step variable equations, okay? So I have one here. This one's a pretty standard one. The goal of this, and anytime you're essentially solving for an unknown, the goal of this is to find out the value of the variable. So you kind of want to point out what the variable is. And in this case, that's relatively straightforward. It's this letter x. It's the only one that's not a numeric value. So we have the letter x as our variable. What we need to do in order to solve it is to isolate it. In other words, get it on one side of the equation by itself. So either look something like this, x is equal to something, or something is equal to x, right? But we want it by itself. That's what our goal is, to get it by itself. So with that being said, we can take a look here. The number 4 is already on the other side, so I probably want to leave that on the other side. My problem here is I have subtract 2 and I have a multiply by 3 still on the same side of the equation as the x. We want to move those over. Okay, so to start off, we have this subtract 2. Really what we need to do is make it a 0. In other words, what we have to do is I need to find out what's the opposite of negative 2. And the opposite of negative 2, or to turn it into a 0, would be the idea of positive 2. Negative 2 plus 2 gives us 0. The only thing is, now I've done that on the left side of the equation, so I'll put a little L dot F for left side and R dot S for right side. Whatever you do to one side of the equation, you have to do to the other. So because I added 2 on the left side, I have to add 2 on the right. And an example of this would be something like, let's say I said 3 plus 5 is equal to 8. This is a true statement. 3 plus 5 is equal to 8. But if I decide to say, you know what, 3 plus 5 minus 2, okay, well, my 8 also has to be subtracted by 2. And now that statement is true. So I did a negative 2 on the left side. I have to adhere a negative 2 on the right side. So that's the concept of balancing an equation, okay? Now, a lot of times they'll just do a shortcut and say when you move it to the other side, it becomes the opposite. And we'll go over the same question with all the shortcuts, but I want to show you the reasoning behind it. So now that we've done that, this negative 2 and positive 2, they cancel out or they create a 0. And I'm going to write the 0 in, plus 0. And the reason being is just because we'll realize to add 0 to anything doesn't do anything. And we'll equate 4 plus 2. 4 plus 2 is actually equal to 6. Now we know 3x plus 0, I can just simplify by writing 3x. In other words, you know, when you add 0 to anything, it changes nothing there. So I'm left with 3x is equal to 6. Okay, same idea. This says 3 times x, okay? What I want to do, whenever there's addition, we want to create a 0. Whenever there's multiplication, we want to create the value of 1. Okay, and the reason being is whenever we're multiplying, for instance, if we have 3 times 1 is equal to 3 times 1, that works out. But if any time we have to do a 3 times 0, that's actually going to be the value of 0. So we don't want to multiply by 0. So to create a 1, if this says 3 times x, I'm actually going to divide the left side by 3, and I'm going to divide the right side by 3. That's that balancing again, okay? And what happens here is we get 3 divided by 3. Well, if we quickly do that on our right side here, 3 divided by 3, we know that that value is actually equal to 1. So a lot of times they'll say this is canceling out, but really what it's doing is creating the value of 1. So we have 1x now, okay? So we have 1x is equal to, and then we can equate the other side, which is 6 divided by 3. That ends up being the value of 2, okay? Now, x isn't technically by itself. I have 1 times x, but what's neat about that is 1 times anything is just whatever the other number is. So 1 times x is just the value of x. So we can simplify this side by just writing x is equal to 2. And then now that we have x by itself on one side, we have an answer. And we've already equated everything on the right side. X is equal to 2. So we've fulfilled this part. We've got that x is equal to something, okay? So that's the long-winded one. I'll say this is the long version. And then I'm going to show you with all of those shortcuts, okay?
Okay.
So 3x minus 2 is equal to 4. We do the exact same thing. We're going to start with negative 2. And instead of saying they balance the equation, a lot of times what they'll say is we're going to bring it to the other side. And when it goes to the other side, we use the opposite operation. So the left side will still read 3x, but the right side will have 4 plus 2. And if we just scroll up just a little, we can see that scenario here. 3x plus 0, that's what we have down here. And 4 plus 2, that's what we have on the right side. So we've done the same thing. We've just kind of skipped a couple steps in this process. So we'll equate that quickly. 4 plus 2 is 6. We already knew that. And here, a lot of times what they'll say is we have 3 times x. So when we bring it to the other side, it becomes divided by 3 instead of multiplied by 3. So they'll say the 3 disappears on the left, and we're left with 6 divided by 3. Okay, and if we take a look up here, that's exactly this scenario. We created a 1, even though they call it canceling out, and we have 6 divided by 3. All we have to do now, or all that's left, is to equate the right side. So 6 divided by 3, it goes in 2 times. X is equal to 2. So this version is a little less messy. But you also have to understand the concept that I'm allowed to do that. I can actually use opposite operations, okay? So anytime you're kind of unsure on what it is you can do, think about that long version and you're always trying to balance both sides. But once you get the hang of it, don't be afraid to try to do these little shortcuts here of just giving it opposite operations when you move it to the other side.